and Sanderson. And would you please welcome them?
All right, setting the mood. Excellent, thank you. I'm Jed, aka James Donaldson with Johnson Fain. And when preparing for this talk, we kind of looked at each other in the studio and said, what do we want to speak about at this forum? And our approach, is more about what we're doing in the studio and how we use the technology in our studio to design buildings. And so I'm going to do the general introduction, but really about the brain power with me, Daniel and Taylor, our leaders in the studio, to speak about more of the details and the specifics. Before we get there, some of you might not be familiar with Johnson Fain. We are in Chinatown, just on the edge of Chinatown, across from the Great State Historic Park. And we practice kind of at different levels. You know, we're kind of a practice at its mid-sized firm. It's led by William Fain and Scott Johnson. And the practice is a mix of urban design, where we're doing large-scale design of campuses, but also city infrastructure. And also at the same time, we're practicing architecture proper, which is a variety of things. We don't do like one type of building and crank out thousands of them. Instead, we take on projects that are more in our interests, that are projecting kind of a design that we're proud of. And it goes from anywhere from tall buildings that are usually housing or office, are also mixed-use projects, as well as mid-rise products, which would be, which you see a lot of infill in Los Angeles right now, of the mixed use, where you have housing over retail, runway of Playa Vista down, if you're familiar with Los Angeles, is one of our recently completed mixed-use projects. We also do office as well. And at the same time, we're practicing at a scale where we do interiors, so we get down to the finer description of materiality and finishes. And then, so that's just a general context of what Johnson Fain does across the board. So we're kind of looking at things, we're looking at problems at different scales. You know, it's not just a building, it could be a campus, it could be a city. And today we're narrowing in our talk about maybe a design process that involves 3 technologies and also a current trend. So the first is kind of a technology I think we're all familiar with, which is Grasshopper, but I think we use it in a way where we couple it with Revit, and it's not just one person doing an algorithm in the dark. It's a person that's working with a greater team to do something that is a documentation that's completely folded in the building in general. Oops. And also, we are working with Dynamo and Revit. Dynamo is something we started digging into about 2 or 3 years ago, maybe 2 years ago, and it's been a discovery process. So in that discovery, we have our own definition of what Dynamo is. It's probably a little different for each one of us, but I think to the question that was asked earlier about like how do you get users ramped up and using this, and how do you get a studio using it, that's what I'm going to share with you today. Is how we have a studio using it, and as an integrated part of a whole team. Our buildings that we're showing, it's a kind of a larger project. It has a project team of about 10 people. It depends where we are in the process. We just completed construction documents on it. So, and then the last part would be latest introduction to the studio, which is visualization software called Lumion. And we have some of our Lumion experts here in the crowd if you want to speak with us afterwards. But, you know, Revit's great in its graphic representation, but we sought out another software to really bring it to a place where we can have an experience and not just a visual for the studio's use, but something we can take forward to the crowd and to the, like this, or whether it be a client, or whether it be a neighborhood council or another entity that architects are making presentations to that are just beyond the studio presentation. So each one of us will speak to a different part, and I think the next part will be Daniel speaking about his experience in our Grasshopper.
Hi, I'm Daniel Ney, and so I'm a designer at Johnson Fain, and I kind of handle Grasshopper as well as documentation and kind of full scope of projects, but typically I'll be working on one project and kind of handle some of these elements. So we see some benefits and some definite drawbacks in Grasshopper. It's very flexible, you can do anything in it, it's very fast, it's mathematically precise, and you can quickly visualize things and tweak them quickly as needed. So if something has to change, you can do it quickly in a mathematical way without having to go back and redocument. It's also lightweight, fast, and adaptable. Some of the drawbacks, though, it's not very compatible with Revit, as most people know. You can break it. People, if they don't know what they're doing, things can go wrong. It takes a little bit of startup time, so sometimes when people want to see a design in the studio quickly, you have to give people a little bit more time to get the script working in a way where it's presentable. And then the other drawback is you can produce something that's really complex that might not be feasible to construct. So the project that I was going to show you this is a building in Washington, D.C. It's a 191 unit, multifamily, type 1. It's got some nice glass sawtooth features, metal panels. This is kind of a high-end building, so we wanted to do a kind of special design for the podium. And on the podium, there's these kind of brickwork elements, so we were going to try and incorporate some parametric design and features into that brickwork. So this was the Grasshopper script I wrote for this, and it's basically just to look at brick and try and perform some different operations on it to see what we could do. So this is just the first part of the script, just putting brick in, pretty simple, it's modular, so this is something good, Grasshopper is very good at. Then making it adaptable, we didn't really select a brick type yet, we wanted to make it flexible, we want to see, Roman brick, Norman brick, just standard brick, it's easy to change. So then we start looking at the construction of the brick, and basically when you do these kind of operations, how it works is it ends up you're taking every middle layer and then we're performing an operation on that. So we separate that out. Then the first one we looked at was just simply performing a one-axis rotation on brick and what kind of effect that would generate. So moving through, kind of pushing that to its maximum limit. And as you can see there, this might not be practical in terms of really building, but you can push the software to do it. But so it's something you can change easily. So then we go to the second design iteration or design operation we did, which was taking the same effect, but applying it in X and Y. So moving through that, you can kind of see how it's moving, and it gives it a kind of a different movement and effect as you go. So we went through all that and ultimately said, well, we might want something that's maybe a little bit more achievable and something that's not quite as complex. So we just looked at taking the general address and performing a rotation on it, and which would be a little simpler to achieve. So when you look at it, you can kind of see, you can get into the details and really tweak it to get exact dimensions and things that are mathematically exact. So as we went along, we changed things quite often. The address changed, the rotation changed. We worked with the masonry contractors to kind of see what you could actually get away with in doing this. So this was some of the final documentation we made for in the studio to present for design options. So this was the first option with just a simple rotation. You can kind of see the effect it establishes there. Then we move forward to the next option, which was doing it in two axes, and kind of has a more varied effect. And then we went forward, and this was another iteration looking at doing it in multiple points and kind of a little less parametric manipulation. Then with the option we finally landed at, which is just kind of doing the address in big super graphics in the brick, which was kind of nice and subtle, which is why we landed on that one. and we thought it'd be more achievable and would probably stay in the budget. We also had another facade where we wanted to explore a few different operations, so we kind of reused some of the scripting we had and then applied it to this facade as well, which was, we took 3 studies, basically randomizing the soldiers of brick, changing the pattern of the brick in terms of porosity and the layout of the bond, and then the third one, looking at trying to actually mold it in a 3D type of form. So these were the 3 options applied to a facade. It was kind of a larger facade to look at, so the pattern was a little bit different, and we came up with modules that were easily repeatable, so you don't end up with a ton of variations. So this was the first design, which was using the soldier and randomizing it to kind of create a fading effect throughout the building. You get a close-up to kind of see. And so when we, how we would do it is we basically do everything in Grasshopper, take it out as a lightweight mesh, because the bricks are a simple form. You can easily put it into Rhino as lightweight mesh to visualize. And then once we had it visualized, we go through design options, figure out what we want to do, and document once we've decided. This was the second option, using basically brick as a screen and changing the opacity, and just kind of, this is more standard brick technique, but it was easy to achieve using Grasshopper. Then the third option was looking at a technique for doing brick in more of a 3D form, which was a study. We didn't go forward with it, but it was a study in how you would kind of achieve that and visualize it, which was pretty interesting to do. And that's the effect on the building. So we use Grasshopper mostly in that way, which is looking at standalone elements, kind of quickly doing design iterations, presenting them in studio, and then luckily we can kind of put it into our 3D Revit model to look at in the context of the building. Then maybe once the studio decides or which options we might want to present or go forward with, we can then kind of look at documentation, maybe take drawings out, tweak details, tweak some of the script to get the design correctly, and then further on we'll keep it native in Revit and everything else. And with that, I'm going to hand it off to Taylor, who's going to talk a little bit about Dynamo and Revit.
Hi, I'm Taylor Sanderson, and I'm a computational designer at Johnson Fain. I work mainly with Grasshopper, Dynamo, and Revit. So I was going to talk about some of our workflows in Revit with Dynamo and how we use Dynamo in the office. So Dynamo in practice, we see a lot of parametric designs done with design iteration and Grasshopper, and there's a lot of wild designs done with that. But how do you use that in the office? How do you use parametric and scripting from a BIM standpoint? So we see 2 paths that we have used in the office: the data model management side and the design iteration side. So Revit's essentially a visual database, and Dynamo allows us to apply scripting and programming language to that database. So if, else, and, or, which gives us massive control over the program. So with the data management side, we have consistency with the model, and once the initial logic is set up, the scripting just executes. So the model runs better, it's faster, it's easier to work with. We can apply firm standards to the project with just a single click, and less time is spent on these tasks. And it also minimizes human error because the initial logic was set up from the beginning. And the other side of things is the design iteration, where we're changing geometry, size, location, materiality, etc. And this allows us to see the changes visually instead of just conceptually as we're talking about it. So we have live updates to the model, which give us the ability to change aspects parametrically, and it shortens the task time. And the best part is that it's Revit native, it's Dynamo, it's right piped into Revit. So these are some of the workflows that I'm going to go over, highlighted there in red, but some other scripts that we use in the office, managing materials, purging families, unifying parameters, duplicating sheets, and then on the design side, we have dot patterns we use, or randomizing curtain grids, analyzing views, or tiling panels. And these have been really helpful in the studio and really cut down time spent on repetitive tasks. So before I get into the scripts, I want to go over this case study. And it's important to emphasize the size of this project, because from a BIM standpoint, it was a challenge to manage. So it's a LA Historic Park adjacent. It's right near our office in Chinatown, and it's 725 units and 6 buildings, and has 8 linked Revit files. And from 7 to 10 team members at a time are working on this file. So keeping things consistent, keeping the model clean was a real challenge, and Dynamo helped us to achieve that. So one of the first scripts that I'm going to talk about was on the data management side. And you can imagine that we had over 1,500 sheets for this project, including consultants and architecture. So to manage all those parameters, we use Dynamo to read from Excel. And so we created an Excel sheet that would had similar parameters that we used in Revit, and then we would pipe that into Revit through Dynamo so we could update, change sheet parameters. A consultant could change something, we would easily change it in the Excel, pipe it back into Revit. And the benefit of this is it's all in Revit. We don't have to export something from Excel and then screenshot it or something like that. It's just all in Revit. Everything's contained inside one project. The next thing is surface calculation, or some volume calculation as well. And with this project, we had over 2 million square feet of surface area. So we would have to calculate, how much stucco or concrete or anything of that nature, or void versus closed, to determine the exposure amounts, percentages, cost, and mainly for coordination purposes. And so the script, we could select certain items, select certain materials, filter out anything we really wanted, and get that number instantaneously, as well as changes are being made back and forth through the team. So this was really helpful in getting those numbers. The next script was on the design side, and so this project, like I said, it has 725 units. Over 80 to 90% of the units have balconies, so we placed all the doors, all the sliding glass doors, and then we would place the balconies. And instead of having to track both the door and the balcony, we created a script to track the door. So we only had to track one item. So if we had to switch out the balcony or change the offset or anything of that nature, or the door moved for a certain reason, we could just move the door, change out the family, and place the balcony through Dynamo. And so that was done by getting an origin point from the door, and you can see it in the point cloud there, and then placing the family based on that point cloud. So the last thing, which we'll get into later on the Lumion side, but on the front face of this building, there was over 3,000 panels, metal panels, and we went through different design iterations, whether the panels were a gradient or ordered in a certain way or randomized or anything really. And we, instead of having to apply materials manually, we decided that a scripting would be the best way to go about this. because the painstaking process of it. So this script you could type in the materials, apply it to these panels, and alter the script in any which way to make a gradient, random, whatever, and then run through a seed value to determine what iteration you liked. So we can go into that. So this is what it would look like as a blank canvas, and the script isn't running, and then we type in the materials, and we apply all the materials. And so Revit doesn't really allow this kind of application in mass or this kind of logic. So this is what we use Dynamo for. And then we run through a seed value. We can change it, and go back and forth between the two, see which one we like. Maybe alter it later, or then alter the script even further to randomize everything, and be able to determine the best possible solution. And I'll pass it off to Daniel here to go into how we visualize this exact thing in Lumion.
So we just got Lumion in the office, I think, about this year, so we're kind of just toying with it, learning what it can do, what it's good for. We found it's not quite a rendering, but it's more like somewhere in between presentation, experiential. We use it a lot in the office as designers as well. So in this project, we use it to see differences in the Dynamo script, to create options, layering materials, tweaking materials, trying to figure out what kind of effect we want on it, representing the model, linking in structural coordination, wayfinding, stuff like that. So this is the example Taylor was talking about, where we have the Dynamo script changing panels. Then we typically take it into a quick rendering, V-Ray rendering, or Revit rendering. And that's kind of how we would look at it before, and maybe we'll do that. But now going into Lumion, we can kind of quickly look and analyze, set the materiality for what we think the panels will be like, what the colors we think they'll be like. Look at it at different times of day, put in more realistic foliage that's coordinated with landscape. And you don't really get the kind of reflections and other items that we find, so it's a little bit better from a designer's perspective. These were some of the coordination items we do in it. Circulation, 3D models, some collision detection for designers. Obviously we don't always get into Navisworks and some of the more complex forms, but it would really help for just putting in and walking through a stairway, seeing if we saw something wrong. So this is kind of one of the examples, just a screen capture from Lumion. So we have the podium coordinated. We put in some of the graphic locations for, we had an artist working on the project, and just kind of looking at the environments. And we found that it was really helpful for both clients and for presentations, because they really like to see the space and kind of go through. They might have questions about areas. Now, one of the kind of drawbacks is we did find, you have to have someone on the project familiar with Lumion, keeping things clean and kind of applying things. So it's not as big a task in the end, so people can kind of use it as it goes. So this was seen kind of structural, underlaid, and coming through. And then the next step would be, you apply landscape and entourage, and it kind of creates a pretty quick and good representation of the project we found. And that's it. Jen?
Questions?
I have a question. That project, those are very common projects now in Los Angeles, and you're supposed to be targeting net zero energy. How did your design process and your tool set address that?
So the question is, how does it approach net zero? Well, the building wasn't designed as net zero, but I think if we speak to kind of what Taylor was speaking about, designing buildings today and energy standards and what we have required for Title 24 and LEED. So we're finding that the software, Revit, has a lot of information in it, but it can't be reached through a native path. So what we have to do is use Dynamo and its ability to go in and dive deeper into the data that's in the model. So for example, the area example, this example, the graphic is like a generic graphic for a presentation, but every building goes through this, right? Every building goes through an analysis of window to wall ratio to help define what the energy calcs and your engineer on the performance of the building, and it then describes from that criteria, describes your glazing, and it describes the envelope system, and it affects costs and everything. So in our ability with Dynamo, we're able to analyze walls in the project and understand how to approach that percentage of window-wall ratio that we don't want to go over. So if it's 40%, and that's the criteria that we're required, we'll stay under that 40%. And if it's designed for another standard, we're able to use Dynamo to access that information in a quick manner and a holistic manner. And so that'd be an example of like how we would use it for envelope calculation. And I think that, I want to be sensitive to the fact that one of my early jobs, I asked my employer, I was like, why don't we do more? Because I was doing small architecture. I was like, we know how this, structure is going. Why do we have a structural engineer? And he mentored me. He said, we have to know our profession and know our limitations and rely on our consultants. So we're hiring consultants to do a lot of the calculations still. What I'm trying to communicate here is that we are hopefully doing analysis in our studio so that we're educated, so we're not blindly just handing over a model and speaking a different language than our engineers. I think the path of architecture is coming around to a point where now architects are coming back to that time when we are having a strong understanding of the whole process, not just artistically, but from an engineering point of view. So Dynamo allows us to start to speak to our consultants in the engineering language and iterate with them in a strong manner. We also have another project that's just completed construction documents. It's Christ Cathedral, and that went through an extensive analysis for energy and solar glare as well. And we did that using Revit and modeling everything in advance of what the engineer was advising us, distributing it to the engineer, who then provides iterations. So to get to net zero, your first pass is not going to be the right pass. You're going to have to do 10 passes or 20 passes. So in that project, we passed on the model to them. They would iterate. They would say panel ABC needs to flip, rotate. So we'd flip and rotate, run the analysis again, pass it back to them. And it was a very successful project of a demonstration of how it's not just the architect saying, I want it to be this way, but the team saying, we need it to be this way to be more efficient.
Can you speak to how you determine whether or not you're going to script something and what the debug process is afterwards?
The what process?
The debug process. So what makes you decide that you're going to actually do it in script versus trying to use the pre-built tools for that or existing add-ins?
Well, from a Grasshopper perspective, what's something?
From a Grasshopper perspective, if it's something visually complex that needs mathematical operation or needs a lot of iteration and change, usually that'll lead to something that we want to script. Or again, maybe Dynamo if it's something that's time extensive where the input of time is well worth it or a tool we can reuse. The brick example was a good one because bricks are highly mathematical, it's simple, and you can apply operations to each individual object. So that's why that one was, we thought, a good example to use for scripting. I don't know if there's something with Dynamo.
Yeah, I think it's also studio-based and task-based where, if we find ourselves doing the same task over and over, or, same things come up on certain projects, then we develop a script or build something for it. To debug it, usually it takes a few iterations to determine whether, it's gonna, another user can use it, or, where the pitfalls are, or, where an error can occur, because, it's not completely clean. It has to be tested by other people, essentially. It's
I just want to speak to the fact that, we have a monthly meeting and we meet about this monthly, not just about Dynamo, but we talk about our practices digitally. And in that process, we educate the other studio members on what's available to them. So if they're approaching a project and they come upon a moment to kind of analyze, do I script this or do I just go do it manually? They at least have, they might not know the path of how to do it or the details of it, but they know, well, we've met and talked about this in the past. And I know that there's a more efficient way of doing it. So then they will make a decision and talk with the team members. Maybe we should go and use that Dynamo script we use on project XYZ that we are developing, and I think I would like to use it on my project. And so it's up to, as Tara said, the studio and the user and the team, because there's also time and you have to have a deliverable in the end that we all can work around. So it's a judgment of the team to make that decision.
Is there another question?
Yeah, well, I have a quick follow-up on that is, it's not so much just deciding the script, it's like how do you scope the time to even develop that script? Is it an a priori assumption that someone already knows how to do that? Or how do you, as a firm, provide resources for people to learn that in the first place so that you even have it available to you when you start your project?
So the way we got there was I didn't know Grasshopper like 3 years ago, and I was like, I want to learn this. So basically, we started a think tank at the firm, and that was a route that I was using to learn Grasshopper, but we as a studio were using as exactly what you're saying, outside of the constraints of a project, to educate and develop this knowledge base in the studio. Because if you try to learn on the project under the demands of a deadline, you're going to crash and burn. So what we did for a long time is we met monthly just about a software. And we had people in the room that were going to execute and follow through on that software. It wasn't open to the whole studio. So if you were in that room, you were expected to perform. We had like assignments and discussions. The next time you came into that room, you had to bring something to the table that was scripted, that something demonstrating something to the rest of the team. And it was through that environment that was met at lunchtime. So you had to sacrifice your lunch, but at the same time, it was just a safe environment to do knowledge share and education. So once we found success in that environment, then we take that knowledge, and those same team members that are having that lunch together, they're all working on projects together, right? So now they go out in the studio and they're like, okay, we were successful with this A, B, C. Now I'm sitting in front of my project, I have a deadline. I know I can do this because we've done it. And then that's how we would implement it. I don't know. Yeah, so that's how we kind of culture. That was the culture that brought it to the table. And it was a process